Let's now move to part 9 of Quadrilaterals, chapter 7. Same section 7.4 and 7.5 examples. We are continuing with the same sections. In the last video, we learnt opposite angles are equal in a parallelogram. This is a theorem we practiced and we learnt in the last part. Again, we are going to practice some examples in this part. What we will learn or what we have learned, we will see at the end of the part. Example 2. Show that the diagonals of a rhombus are perpendicular to each other. Hope all of you know what is a rhombus. In the second part or third part, in the types of quadrilaterals, we have already discussed. In the types of quadrilateral, then subsequently types of parallelograms, what is a rhombus? In rhombus, all the sides are equal. I have put some properties also. So, we are going to see in all these examples, one property what we have put, we are going to prove that. It's all very interesting chapter. So, you will be able to not only learn or remember, you will be able to prove that also. The moment you prove it by remembering the theorems, then automatically all these concepts will be very clear to you and you will remember without even referring the notebook. So, now I have given the rhombus here, the diagram. You can see the single dash, double dash and triple dash. So, these are already show that the diagonals of a rhombus are perpendicular to each other, because we know that a rhombus diagonals are in a parallelogram. You know the parallelogram opposite sides are equal. In a rhombus all sides are equal and the diagonals bisect each other is already known in a parallelogram. Whereas in rhombus we are going to prove that it is not just bisecting, it is going to bisect at perpendicular to each other. That is what we are going to see now. So, here AB equal to BC equal to CD equal to DA, all sides are equal. That is a property of a rhombus. And AO equal to CO, BO equal to DO, diagonals bisect each other. It is again a property of parallelogram. Therefore, triangle AOD is congruent with triangle COD. So, again as I told in the last part, I am not going to explain in detail, but I have put all the points here. This is following SSS congruence rule. You can see AD equal to CD. You can see the path also AOD. See here AOD equal to COD. So, AO is following double dash, CO is following double dash, OD is following triple dash, OB is following what I have written COD here, AOD, COD, because OD is common and AD is single dash, CD is single dash. So, AOD it comes back single dash, COD it comes back single dash. So, what has happened? AD equal to CD, AO equal to CO and OD is common. Because of this, all the three sides are equal in both the triangles. So, both triangles are congruent with each other. Angle AOD equal to angle COD, corresponding parts of congruent triangles. Correct? So, which one is that? Angle AOD, COD. You will also see, I will put the color also. Yes, I have put the angle symbol. So, both are equal. Angle AOD plus angle COD equal to 180 degrees. It is linear pair. All of you know. Therefore, AOD equal to COD equal to 90 degrees. Thus, prove diagonals of a rhombus are perpendicular to each other. Right? So, DO is perpendicular to AO, AC. So, clear that we have just proved one, that is sufficient. The moment you prove one, automatically the other one is proved. So, that means the diagonals of a rhombus are perpendicular to each other is proved. Now, pause the video, note down the steps before going to the next example. We will go to the next example, the next page. Example 3, ABC is an isosceles triangle. You can see there in green color, ABC is an isosceles triangle in which AB equal to AC. It is already given, I have put single dash. AD bisects, you can see AD bisects angle PAC. Where is there? PAC. So, this angle PAC PAC angle is bisected by AD and CD parallel to AB. These are all whatever is shown in this page, these are all given in the textbook. This is given in the question itself. But we will be seeing more like this symbols in the next page. Now what we have to do, that's going to come now. Show that there are two questions here. Angle DAC equal to angle BCA and ABCD is a parallelogram. These are the two proofs we have to, two questions we have to prove, two statements we have to prove. We will go to the next page, how to do it. I would also suggest you can first think how to do it. Now you have learned so many theorems, you can just think how it is possible to do it and write your answer and then move to the next page and see how the steps are derived by me. So step number 1, angle CBA equal to angle BCA. CBA, so I will see the symbols now. CBA I have put in blue equal to angle BCA. What is the reason? Sides opposite to equal angles are equal. This is in the isosceles triangle, we have already learned this property, learned this theorem. Then angle PAC equal to angle CBA plus angle BCA. Exterior angles theorem. You can remember one now, you can note one, we are continuously using triangles property. So that is why when we were studying this triangle property, theorems of triangles, I told repeatedly we will be using triangles and also lines and angles. Parallelogram is just an extension of a triangle. So some of the whatever properties or whatever theorems we have proved in parallelograms, all we have used only lines and angles and triangles. So those two are extremely important. Therefore, angle PAC equal to 2 into angle BCA, because CBA equal to BCA, so it becomes PAC equal to 2 into BCA. But PAC equal to 2 into DAC. The reason? Yes, AD is the angle bisector of PAC. Therefore, DAC, PAC both are equal. Because of that, PAC is also DAC and PAD both are equal. Therefore, PAC is 2 into DAC. Now we can see statement number 2 and 3 both are having PAC on LHS. Statement number 3 and 4 both are having PAC on the LHS and 2 also on the right RHS, all are getting cancelled. Therefore, angle BCA equal to angle DAC. So you can see the symbol here. Symbol I have already put. Angle DAC, you know already blue color is there, equal to angle BCA. So the first one we have proved already. The second question, we are moving to a second question now, in that AD is parallel to BC. How? Converse of alternate interior angles theorem, AC is a transversal. Now you can see AC is a transversal, AD is parallel to BC because angle DAC equal to angle ABC. So angle BCA. Angle, just previous one we have seen, angle DAC equal to angle BCA, that means AD is parallel to BC where AC is a transversal. So this parallel symbol I have put now. Now you can make out what is the next step. Think about it, parallelogram. Yes, very good. I am sure many of you would have got it, or most of you would have got it. You can see the green symbols, green parallel symbol and blue parallel symbol. Again, only in this example I mentioned all these things, symbols, parallel symbol, which is not actually a standard symbol, but I have used only for your easy reference. This I will not be using in future examples. You will be able to understand the moment you see the step itself. In 6th step I have written AD parallel to BC and AB parallel to AD, this is AD parallel to BC we have proved now, but AB parallel to DC is already given in the question. So next step is ABCD is a parallelogram because each pair of opposite sides is parallel. Right? That is one of the theorems we have proved. So BC parallel to AD and AB parallel to CD. Therefore, each pair, that is there are two pairs, both the pairs are parallel to each other. Because of this, this ABCD quadrilateral becomes a parallelogram. Alright, hope all of you have understood these steps. I will just put one more that box. No, all remember, in any proof, what all you have to do? Think about it. 3 things I have told. Yes, correct. Step by step, you can see 1, 2, 3, up to 7 I have put. Step by step you have to put, and that is the first point. And in each step, we have to put within the bracket how you have arrived at that particular step. You can see in almost all this, in all except in 3, because it is just from 2 we have derived 3. So everywhere you will see in the bracket on what basis we are able to tell that step. And the last point is you will see the box. I am putting the box on the diagram itself because there is no space in this page. Thus proved DAC equal to BCA. I have not put the angle symbol because there is no space, and ABCD is a parallelogram. But when you write in the notebook or when you write in the exam, write it separately, put the angle symbol also. Now what I will do, I will just remove that rectangle that thus proved I will remove, so that you can pause the video, note down all these steps, and then you can move forward so that it doesn't interfere with your understanding. I am going to remove that, then you pause the video. Yes, let us move forward. So in this video, we have learned diagonals bisect each other in a parallelogram. In one of the examples, I think in example 2, we understood diagonals bisect each other in a parallelogram. If you have not understood, go back to the video example 2 and thoroughly understand. Correct? So in what property of parallelogram we learnt in this video is what I have written. Besides, we have also again practiced some of the theorems of triangles, like exterior angle we saw lines and angles, that is converse of alternate interior angles we saw repeatedly, we are seeing lines and angles and triangles properties also. But in this examples, I will be writing only parallelogram theorems which we have proved in this chapter. Again, next video is going to be similar, some other example you are going to see. Questions, this is one page only. The first 2 are textbook questions, question number 1 and 2. Again, as I told in the last part, the question number will be different in the textbook. Number will be different. I just put 1, 2 for your understanding, and 3, 4, 5 are questions given by me. So totally 5 questions are there. Pause the video, note down the questions, and then move forward. That's all for this video. Thank you.